Weird things are happening in the world you think you know. Clocks on planes show that time itself ticks differently depending on speed and height. In a lab in Australia, scientists made particles behave like they were interacting with their own past selves. And are we all misremembering the Starbucks logo? These are anomalies in time. Did CERN alter our reality? At CERN, scientists smash particles together at insane speeds. Most of the time what comes out is messy and random, but a few years ago they noticed something strange. Two particles created in the same collision were acting like they were still connected to each other, even after they flew apart. These particles are called top quarks. They only exist for a tiny fraction of a second before they break down into other particles. They disappear so fast, you'd expect them to act completely independently once they're gone, but when researchers looked closely, they saw patterns that didn't line up with that idea. What they found was that certain properties of one particle were linked to the other one, meaning when one behaved a certain way, the other matched it. That kind of connection only happens if the particles are entangled, but these particles were not sitting next to each other. They were created in violent collisions that immediately moved apart. There was no time for signals to pass between them in any normal way, yet somehow the connection was still there. This was entanglement happening at the highest energies humans have ever reached. It seems that at a very basic level, the universe doesn't always behave the way we'd expect it to. Now, anyone remember Wii Sports? I used to play it all the time. I got pretty far in my virtual boxing career in this game. I could still hear that announcer exclaiming those two beautiful words, "You win!" Only that never happened. I mean, me winning happened. I won so much, I'll tell you, but there's no announcer that actually says, "You win." User Rampos7 posted on the Mandela Effect Reddit, writing, "I was building some contraption and decided that I wanted to use a sound effect of the Wii Sports announcer saying 'You win.' I can hear him saying it in my mind's eye. I asked other people I know and they all agree that the announcer says 'You win.' He of course does not. Did anyone else think that he did?" And I pose that same question to all of you. Yes, you specifically. In 2012, something strange showed up in real particle experiments studying B mesons, which are short-lived particles created in huge numbers at particle colliders. Researchers at the Babar experiment in California looked at billions of these particles and how they changed over time. What they found was that certain transitions happened more often in one direction than they did in the reverse. So in other words, the forward behavior didn't match the backward behavior. One report described the findings like this. Scientists, quote, found that certain particle types change into one another much more often in one way than they do in the other, a violation of time reversal symmetry. So what does that actually mean? Well, when these B mesons behaved one way, there wasn't the same chance of seeing them behave the opposite way. If time truly worked exactly the same forward and backward, these rates should match, but they didn't. Scientists saw an imbalance. That doesn't mean particles are traveling back in time or whatever. What it does mean, though, is that at a very tiny level, the universe seems to prefer one direction over the other. In normal life, we still only experience time moving forward, but deep down, the rules may not be as black and white as we thought. Picture the Starbucks logo. Probably pretty easy for most of us. I mean, in a lot of places, Starbucks is inescapable. Tell me which of these logos you think is accurate, though. It's the one with the star. But people are pretty divided by this. There are a lot of people who have absolutely no memory of that star. Granted, a star makes sense. I mean, the place is called Starbucks, but I mean, there's no King's Crown in the Burger King logo. This image was posted to Reddit, and one commenter said they work at Starbucks and have never even noticed the star. So, what do you all think? Share your thoughts down below. In 2014 and 15, a team of physicists in Australia published work about something called closed time-like curves. A closed time-like curve is just a fancy way of talking about a path through space and time that loops back to itself, like a particle going out and then somehow coming back to meet its earlier self. In real life, we have no idea if this is actually possible, but scientists found a clever way to imitate what that might look like in a controlled experiment. In the study, researchers built a lab experiment that didn't literally send anything into the past, but it did mimic what would happen if a particle could interact with its own past self. They used a tiny particle called a qubit, and they used another qubit to act like the, for lack of a better term, past version of the first one. By carefully controlling how these two qubits interacted, they created a situation where the first qubit's state would affect the second qubit, and the second qubit would affect the first, just like a loop through time. What they were testing is the idea that if time could loop, particles could behave in ways that normal physics would not allow. In the experiment, the qubits ended up in states that are impossible if time only moves forward. For example, they could solve problems that normally quantum particles couldn't solve, like distinguishing between states that are normally indistinguishable. Here's a fun fact. Clocks in different places really do measure time differently, and I'm not talking about clocks being busted. In the early 70s, physicists Joseph Haffel and Richard Keating took atomic clocks aboard commercial airplanes flying around the world. They compared those airborne clocks to identical clocks left on the ground. After the flights, they checked all the clocks. The ones on the planes didn't match the ones on the ground. The clocks that flew eastward lost time compared to the ground clocks, and the ones that flew westward gained time. This happened for a very clear reason according to Einstein's relativity. A clock that moves fast relative to you ticks more slowly. A clock deeper in a gravity field ticks more slowly than one higher up. Both effects showed up in the flying clocks. The ones moving fast and closer to the Earth age differently than the stationary ones. Engineers even have to correct for these effects in the GPS satellites that tell your phone where you are, because if they didn't, GPS would drift off by kilometers every day. So time itself doesn't flow at the same rate everywhere. It's almost a direct, measured anomaly in time. This next story comes from a now deleted Reddit user who described a possible glitch in reality while walking through their neighborhood. It goes as follows. So this happened to me yesterday, and I'm still trying to figure it out. I live in a quiet suburban neighborhood, and I usually take the same route when I go for my evening walk. Yesterday, I left around 7 p.m., headphones in, same path as always. About halfway down the street, I noticed something weird. The same kid on a bike passed me, going the same direction I think I passed him earlier in the day. Okay, not too strange, maybe a coincidence. Then I saw my neighbor's car parked in the driveway, but it had a completely different license plate than it usually does. Then I walked past another house I passed literally every day, and the front porch decorations were exactly the same as a week ago. Not changed at all. I'm positive, though, I saw them swap out the decorations a few days ago. By the next morning, everything was back to normal. My neighbor's car was the right one again. The decorations had changed. But I can't shake the feeling that I somehow walked through a glitch in reality. When spacecraft swing past Earth, they use the planet's gravity to pick up speed and slingshot toward their next destination. Scientists calculate these flybys extremely carefully. Every curve, every boost, every tiny push of gravity is predicted to incredible precision, but in some cases, spacecraft come out of these flybys with a tiny bit more speed than expected. It's just a few millimeters per second, but it's enough that it can't be ignored. Multiple missions, including Galileo, NEAR, and Rosetta, show the same thing. The numbers just didn't match their calculations. Nobody fully understands why it happens. Some theories involve weird interactions with Earth's rotation, the planet's shape, or even something in the spacecraft itself, but so far, no explanation fits all the cases. Some scientists call it a kind of time anomaly because, in a way, the spacecraft's movement over time doesn't line up with what our physics predicts. Black holes are already strange. They warp space, bend light, and crush matter. They also mess with our understanding of time itself. Back in the 70s, Stephen Hawking discovered that black holes slowly lose energy by emitting what we now call Hawking radiation. That means they can shrink and eventually disappear, but according to the math, any information that falls into a black hole could be lost forever, and that breaks a core rule of physics. Information can't just disappear. Everything that happens in the universe leaves a trace. If black holes destroy that trace, well, what's going on? Physicists call this the information paradox, and it's still unresolved. We don't know exactly how time and information behave inside or around black holes. This doesn't mean time travel is happening, but it does mean that in some of the most extreme places in the universe, some of our most fundamental theories about time, cause and effect, and the flow of events doesn't fully line up. That's been the video for today.